In the last video, we discussed the idea of a confidence interval and looked at this general picture to understand what it would look like if we constructed our interval using p hat, since we don't know p. So we discussed at the very end of that video that we want this percentage or proportion to be quite large, this probability of containing p, and the probability that we're outside here to be quite small. So our goal here, we'd have this to be a relatively large number, and so depending upon what number we put in here, we're going to have to go out a different number of standard deviations. We had already learned from the empirical rule or normal curve rule that if I go out one standard deviation, I get 68%. Well, that's not very much. If I go out two standard deviations, I get 95%, and if I go out three, I get 99.7%. But I don't have to just use one of those three numbers. I can really use any number I want. All that's going to change is the z that we're going to use, or basically how many standard deviations we need to go out. So let's first understand what this picture would look like if I were going to be 98% confident. So not a number we've already seen before. So taking this general picture and deciding what it would look like for this specific problem. So when I'm calculating my z, remember z is always centered at 0. I'm going to take however confident I want to be, and that's what's going to go in the middle. So I'm going to have that 98% or 0.98 in the middle. If I have 98% in the middle, I have 2% left over in two different spots to split it up between. So I'm going to put 1% or 0.01 on either side. Then to find my z-score, I really want to find this number along the bottom. This is going to involve us having to use our z-table. So I'm going to pull up our z-table here. And sort of remind you of what we're looking for. So remember, it always gives you what's to the left of the number. Right, positive z-scores on one page, and all the negative z-scores on the other page. So when I'm looking for this number, I've got to think about how much is to the left of that number. Well, so what I would go to the table looking for is everything to the left of that number. So I'm going to be looking for 0.98 plus that little 0.01. So I'm going to be going to the table looking for 0.9900. And that 9 does not look very good. There. And so if I pull up that table here, what I want to find is that 0.9900 on the inside of my table. And if I look for the closest thing I can find, there's this 0.9901, and that corresponded to a z of 2.33. So then drawing my picture, that would mean my z down here would be 2.33. And so why don't I have to find the one down here? Well, because z is symmetric about 0, this then is just going to be negative 2.33. So if I want 98% confidence, I'm going to go 2.33 standard deviations on either side, is what that picture is telling me. So that's just a refresher of sort of how we use that backwards normal table. Now, since we've already done that before, I'm not going to make you do this every single time. So I'm not going to make you find these directly, so you can actually write the following on your z table. So I will only give you confidences of 90, 95, 96, 98, or 99%, and then this tells you how many standard deviations we would need to go out. If we look at that 95%, you'll notice that it's not exactly 2, but it's really close to 2. So that's where that idea of the empirical rule is coming. So if I want to be 90% confident, I'm going to go out 1.645 standard deviations. If instead I want to be 99% confident, I'm going to go out 2.576 standard deviations. You may wonder, why do we not always just use a very large confidence? We will cover that, just not in this video. So this video was primarily to talk about where the z-score is coming from. But now let's actually move that on to how we're going to use it. So now that I know how many standard deviations I need to go out, so again, like if we're 90% confident, we'll use a z of 1.645. Let's look at what the actual calculation should look like. I'm going to take my value of p hat minus my z, and again, that z is just going to come from how confident we are. So we're just going to pull that number from my little chart there. And then we have the square root of p hat times 1 minus p hat over n. So if we go back to what this formula looked like in that first video, p hat is taking the place of p in both of those locations. And this 2 is now just a z. But 2 here measured how many standard deviations we were going to go out for that 95%. So now we're just putting a general letter so that you can pull whatever z value that we need into that formula. So again, some terminologies here. So p hat is our sample proportion. Again, that alpha, when I drew that picture, is the percent that's not in the middle. It's the outside part. Z is just how many standard deviations you're going to be away. And again, it's based upon your confidence level. If you're reading the textbook, you might hear that referred to as a critical point as well. A couple of other new terms just for understanding, and it's going to be helpful, especially as we go further in this module. The first one's what's called a standard error. And a standard error is just an estimated standard deviation. And so what do I mean by an estimated standard deviation? Well, technically, remember, our standard deviation of p hat is the square root of p times 1 minus p over n. However, if I look at my formula that I'm using now, that's not quite what I have. Instead, I have this hat on my p. So as soon as I've done that, it's now an estimated standard deviation because I replaced p with p hat. So here in our example, that would be this square root of p hat times 1 minus p hat over n. Now another term we talk about is margin of error. So what is a margin of error? It is how far off we believe we are. So some of you may have seen some reports that say, 25% plus or minus 3%. That plus or minus 3% that you be seeing is what we call a margin of error. It's how far off we believe we are. So first, thinking about our example we introduced here, right? So we got a sample proportion of 29%. Okay, how much do we think that's really off? That's the idea of what a margin of error is doing. How are we doing that calculation-wise? Well, we're taking that p hat, and we're subtracting something off, and we're adding something off. So that's where that plus or minus idea comes from. Well, what are we adding and subtracting? If you notice, is exactly the same thing. So that whole z times that square root piece is actually our margin of error in this example. So if we kind of go back up and label this, if I look at just the square root piece, not including the z, that's our standard error. If I include the z with it, that's what we would call our margin of error. And so we will look at how those are in an actual problem, so you can see the numbers that would be attached to those as well. So we'll do that when we get to our first example. Your next video is just going to go over the steps for doing a confidence interval, because just as with hypothesis tests, there are certain steps I'm going to be expecting you to do.